Now, just as we can make frequency tables or cumulative frequency tables with numeric data, when we're dealing with categorical data, we can make a similar chart, and it's called a Pareto chart, and it measures the frequency of outcomes, or how often things occur. Now, sometimes the order really doesn't matter. For example, if I did a survey of the colour of cars in our Year 12 car park, I might come up with a list before I went out with my clipboard to do the tally, and then I might go out there, spot how many cars I could see of each colour. I might group together some colours that I don't think would be very common, and I'll come up with a frequency for each. Now, sure, it's possible that I could then say, I'm going to reorganise this list so that black is at the top because we had the most black cars. On the other hand, who's to say black needs to be at the top? Because if I was to actually get a good sample of Year 12 car parks around Australia, perhaps this is my scores of what I got, but there's nothing to suggest that other Year 12 car parks are always going to have their most common colour being black. So really it doesn't matter what order I list these in, and it's kind of random. But for a business application, the order can be really important because it shows what you might want to fix first. So for example, let's say I'm the boss of a company that repairs roofs, and some people have been complaining and saying, you haven't fixed our roof, what's going on? Now, as the boss, I would want to work out why the roofs haven't been repaired. So if I came up with some ideas that I thought might have been the reason and did myself a bit of a survey to find out what was actually the cause of each roof not being repaired, then if I just list them in a random order, I can make a frequency table. Here, a cumulative frequency table doesn't make much sense because it's not as though the order here has any real bearing on anything. It's been done quite randomly. But if I was to write it in a different order, it makes a lot more sense from a business perspective, because if I've had, say, 200 roofs that haven't been repaired, and 88 of those times it was because it was raining, that's the biggest reason for things not being done. And so I could say, well, we couldn't help the weather, and I've got something there that doesn't really need investigating, we couldn't help those ones. And without this survey being done, I might be thinking, oh, it's because people are away or their trucks have broken down. But having run the survey, I'd be able to say, well, no, people being away actually is not one of the main reasons this happens. And so I can list my problems in order of importance, if you like, of which one's been the biggest problem, down to which one's been the smallest problem because it's happened the fewest number of times. So the owner not home is the second most common, the truck breakdown, etc. Now, once you've listed them in an order that actually makes sense for a specific reason, i.e. you're wanting to fix a business, so you want to look at the biggest problems first, now a cumulative frequency chart does make some sense. Because as we add up the cumulative frequency here, and you'll notice that we have 200 complaints, so altogether by the time we get to the end, you can check that you should be at 200. This makes some sense because I can say, well, what's the problem most of the time? And it depends what you like to term most. I could actually say, well, 152 out of the 200 times, it was either this or this. And so that gives me then two problems that I could investigate that will cover most of the problems. Or I could take it down to here and say, look, it was this many. Now, you are probably thinking, well, there's 200 people. Wouldn't it be handy to know what percentage of the problems are caused by each thing? Yes, it makes a lot of sense, and we call this the cumulative percentage. So if I say of the 200 problems, what percentage of them were caused by each thing? Obviously 88 out of 200 is 44%. But I can actually make a cumulative percentage going up so that by the time I get to the bottom of the chart, I've thought of what causes 100% of the problems. It's one of these 6 things. But I could also make statements like 95% of the problems were caused by these 4 things. And that way I can group problems together and have a reasonable amount of confidence how much they sort of added up to. And the data becomes more meaningful like that. Now this information, the cumulative percentage and also the actual frequency, can be plotted on charts. Now you can plot it on one chart or the other, or often you'll see 2 things plotted on the same chart. So on this chart here, on the left-hand side, we've got the frequency of how often these various problems occurred out of the 200 cases that were investigated. And we've got the 6 problems listed here. And we can see that we've ordered them from the biggest problem down to the smallest problem. And visually, that's a really nice way of identifying straight away what the big problems are. At the same time, we've listed the cumulative percentage in purple here, So you'll notice on this axis on the right-hand side, it goes up to 100%. So by the time we've accounted for all 6 of these problems, we've thought about what causes all 100% of the problems. But it also allows us to see at a glance that we've got the top of the box here. We can see that 44% of the problems are caused by the rain. And then going up from there, we have the height of each box added on. And so as the boxes get progressively smaller, the dots, which would equate to where the top corner of that box would be, get progressively closer together and they even out towards the top. So 2 different pictures on the one graph.